Good morning, gentlemen. Here's some more stuff. They're called the RC2014 board that we assembled the other day. That's just the CPU card. And I've basically, just ignore this shit right here. That's for the next part. That's the ROM and RAM and the partial address decoding there in the center. But, so basically here I've rejiggered that no-op generator that we made before on the breadboard. But this time, the clock being generated by the ESP32, this actually has some VGA output firmware on it right now, but I'm using the pin for the 31.5 kilohertz VGA sync signal, which is a TTL signal. It's not a 50% duty cycle square wave, but that CPU is rated to 10 megahertz, so I think that'll be plenty slow and it'll clock the thing fine. I just didn't want to fuck around putting different software on it. Everything's tied together here. We've got it hooked into our 5-volt power supply there, and we have all of the data lines on the CPU grounded over here, so it should just start generating no ops, and we should be able to probe the address lines then and view traces on the oscilloscope and make sure that it is doing what it's supposed to do, pretty much exactly the same thing that we did before. So just want to make sure that works before we go on to building the actual clock card. So first let's see if the magic smoke comes out. Okay, I had a major fuck up. I hope I didn't blow up the CPU. Let me show you. See the CPU card here. These single row headers are 40 pins long, alright? But the CPU card is only 39 pins long. This end pin is supposed to be empty. And I had plugged the CPU card in one pin back, assuming that this was a 40 pin header. So it was applying 5 volts to what should have been the ground here, and it's hard to tell what the fuck else. Unfortunately, as a result of that fuck up, we seem to have fried the CPU. Note that it's set to 2 volts per division. That's the A0 line. If we move it up here to A1, you'll see that it jumps to 5 volts like it's supposed to and doubles its period. See, there's A0 running about 2 volts, a little bit less. A1, A2, A3. So the CPU is still technically working, it's just that some of the output voltages aren't high enough. So I guess we fried that CPU. Let me put another one in and see if that fixes it. Alright, here we are on A0 with a new CPU. Working how it's supposed to. Alright, I'm gonna say it. I apologize if I offend anybody. RC2014 is cool and all, but making your cards 1 pin shorter than your bus so that it's easy to plug them in wrong and fuck something up is absolutely retarded. Absolutely. 150% retarded. I mean, obviously it's my fault for plugging the card in wrong, but, you know, one assumes that the card is the same width as the bus, or at least not 1 pin off, you know what I'm saying? Well, I guess it's not like I blew up something expensive, but that's still annoying as fuck. Alright, now that we have made the CPU card work after breaking it and then made it work again, so let's tear this apart and assemble the RC2014 clock card. Alright, here's the clock card. It also implements a power on reset circuit. The master clock runs at 7.328 megahertz because that is a frequency that is convenient to use with the serial ports as well. The serial the serial card doesn't have its own oscillator, and it runs off of one of the clocks on this card. So it generates. It can generate two clocks. There's a main clock, and there's a clock 2. You can see them on your back plane up here. Clock 1 is what the CPU runs off of, and it's also what serial port number 1 runs off of, which also happens to be the console serial port, and that also means that in the default configuration the console serial port is locked to 115 kilobaud, which isn't going to work with my slow old Zenith serial terminal, which runs at a maximum of 9600 baud reliably. It's got a 19.2 setting, but it drops characters at that setting. That's a problem, but it's not the fault of the clock card. We'll probably just have to modify the serial card to run off of clock 2, and then we'll be able to change the baud rate of the primary serial port. This thing also implements a slow clock. I don't remember how fast it is. It's some slow amount of kilohertz. So you can watch the blinking lights if you're doing that kind of shit. And it also has a manual clock, which runs through this switch up here. Now that's it. The slow clock runs off of an RC circuit and a couple of inverters. The manual, the step clock runs off of this switch is debounced by some NAND gates, I think. Probably. Yeah. I think that's how it works. It's kinda interesting. You can change all the clock frequencies with these jumpers here, so that's kinda useful. Let's put it together and see how much we can fuck up. I think it's straight. Ooh. Oh, I got it off without bending anything. I'll be damned. What is the world coming to? Alright. See there, there's closely spaced holes again. You gotta bend those leads so tight. $10K. Now let's see. 1K is going to be brown, black, something, a different multiplier value. This is probably it right here. Brown, black, red is 1K. That sounds about right. 1K. Yes, indeed. That'll do for them. There's a big ugly fat head in the way. Probably is. I was wrestling calves this morning, rolling around in the mud, so it's probably a nasty old filthy head if you're seeing it. Oh well. If you don't like my dirt, too bad. Some of us have to work outside, even on Sundays. Lee, you're so anally retentive, you're saying. Yes. Yes, I am. I put stuff off forever because once I start, it has to be just right. It's a very unfortunate way to be. There's a diode that goes in here. Did we have a diode in our shit here? Yes, yes we did. Now, the diodes, being diodes, are polarity sensitive. It would appear that it goes that direction with the band facing down. Diodes, if you weren't aware, can get fuckerized by too much heat. So if you're a new type soldering guy, be a little careful-rated with your diodes and don't fuctorate them, or you will be sad inside. Alright, what shall we do next, boys? We've got a crystal. We have some 22 picofarad capacitors. I would say that the crystal's probably going to be the next tallest thing. Crystals can also be fuctorated with too much heat. Is it centered in the silk screen? No. Oh, the anal retention is high today. Yes, it is. Alright, what all we got here? We got an LS04. Now, if you're following along in your own man cave, assembling yours, note that I am soldering these chips onto the board to save sockets and increase reliability. I would not do that with a fancy expensive chip like the CPU or something, nor would I do it if I didn't have a desoldering gun. So if you're follorating at home and you don't have a desoldering gun, you should probably use the sockets instead of soldering the stuff straight to the board. LS0. Oh, some kind soul, probably myself, has already straightened the pins on that one. Must have had it in a breadboard somewhere. Very nice. That's a really old IC right there. Huh. Alright. 393. 393. What the hell is an LS393? It's a 4-bit decade counter. Ah. I do have an HCT 393 in my stash that I salvaged off of something, but I don't have an LS393. Problem is that HCT 393 is what, depending on which jumper you've got these set to, feeds directly into the clock pin on the bus. So despite having LS logic here behind it, when we're not running the slower manual clock, it's the bus itself is still going to be driven by that HCT logic. So I'm going to go ahead and stick that in a socket, and if at some point we discover that the clock card doesn't have enough ass to drive some of the shit on the bus, then we can replace it with an LS part, although I'll have to buy one somewhere to do that. Is that the right size socket? I picked it up at random from the shit that was laying on the bench. No, it is not. These 3 pads here hit different pins on this ripple counter. I'm not sure what the purpose of those is. I've got half a notion to solder this right angle header into the back side here, because once the socket's in there I won't be able to get to it, and then if I ever need to use those signals I'll have a a way to get to them a little easier, you know what I'm saying? I don't see anything about those pads on the wiki for this thing. I don't know, maybe I'll just leave all of this for last and then check shit off of the bill of materials and see if there's anything left that was supposed to go in there. Alright, next is the 74LS74 bin. Good old flipper rotarator. And the 7402. That'll do. Alright. What shall we do next? Capacitors, I reckon. Alright, we got a couple electrolytic capacitors, a switch, and some headers to go, I think. Might as well just do the switch, it's pretty small. You know, maybe I ought to put a right angle header in there so it's a little easier to put jumpers on it. You think that would help? I mean, it wouldn't hurt anything. Yeah, let's do that. Yeah, I believe that'll work. Now we've got those two electrolytics and whatever we're going to do with those three pads right there. What could be the purpose of those? I'm pretty sure that both of these electrolytic capacitors that came with the kit are China junk. I don't know if I've got anything small enough to go in there. Let's see, we need a 47 microfarad. Oh, that'll fit. We'll just have to do a little bit of creative bendy winding. Yeah, that's a 63 volt capacitor, but that's all right. It'll just last longer that way, right? Right. And the other one we need 22 microfarad. What do we got here? We got, those are China junk. What do we got here? That's a good one. That's a good one. 22 microfarad, right? 100 volt capacitor. Well, I hope we're not running this board at that voltage anytime soon. Ought to get some smaller capacitors one of these days, huh? Oh well. That'll do. Alright, what am I forgetting? That bullshit right there. I'm gonna go back over the bomb and check stuff off and see what's going on with those 3 spots. Well, boys, I done fucked up. That right there is supposed to be a 1 meg resistor, not a what was it, 1K that I put in there? Oopsie. Dummy dum 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 dummity dum dum. Stupid. Dumb. Dumb dumb dummy dumb. Dumb. I'm dumb. Hey guys, did I mention that I'm dumb? Yes, sir. Oh, come out of there, you dirty, rotten such and such. Alright. Yep. That says 1 meg, doesn't it? Oh, hurdy-dur. Hurdy-dur-dur-dur-dur. I'm glad that I noticed that. Well, I don't know what those 3 pads are for. If I stick a right angle header in there, I'll be able to get leads onto it if I have to. And it won't stick up too far to fuck with other cards in the back plane. It'll be a little difficult to solder that socket under there, but I believe I'm going to do it anyway. Try to angle that up a little more. Yeah, I can get DuPont connectors onto that. It'll be fine. It'll be fine. Nothing to worry about. Nothing to worry about. No problem at all. And then we stick our socket over top. Right? Yeah. That will be a little bit challenging to get down in there to solder, won't it? I hope I didn't just fuck up. Yeah, okay. Here goes nothing. I may not be able to do this without getting my head in front of the camera. Sorry about that. I believe I got it. Yes, sir. Didn't get any solder on the header. I'll be fucked. Well, we're not done yet. I can still screw it up. I can still screw it up. Now, if we ever have to remove either of those, I'll have to just cut the socket off, I guess. But there will be no way to get a desoldering contraptificator down in there. That's alright, I guess. Well, I think that'll work. I'll have to get an LS393 to put in here sometime. Well, let's clean the flux off the board before we put that chip in there, and then I guess it ought to be finished, I guess. Socket that decade counter. And then try it. those big old capacitors were just about too long, weren't they? But it fits relatively straight. Good, good, good. Alright, let's see if the magic smoke comes out. We've got it rigged up again as a no-op generator, and we've got the scope, not the new scope. I need to do some rearranging so I have room. We've got the scope plugged into A0, so we ought to be able to do some probe-rating and see that divide thing. So we'll hit the juice, ease the current up. So the slow clock that runs off of that RC circuit and a couple of inverters is working, and that's the M1 line on the bus right there, running with the slow clock. But the crystal oscillator is not working for some reason. I don't see any activity on the crystal or anything, so this is going to bear further investigation. Well, it's working now. I got my comeuppance for trying to substitute LS parts in place of HCT. I'm not sure why in this case it would make a difference. I guess it has something to do with how the crystal interacts with the gate. Maybe they're doing something funny that requires CMOS voltage levels out of the HCT chip's output or something. I don't know. I thought I had a bad inverter. Ended up desoldering the inverter and soldering a socket in and put another one in there, and it still didn't work, so I rebuilt the circuit with different components on breadboard here, just in case it was one of the passive components or something, and it didn't work either. So I was like, what the fuck? On a wild hair, I plugged one of the HCT chips in instead, and it started working, and so I did the same here, and lo and behold, it works. But yeah, I guess that's what I get. I've got enough LS series parts to choke a buzzard off a gut wagon. I bought a whole bunch real cheap at an auction a long time ago, and I've had them for quite some time. But I don't have a tremendous number of HCT parts in my stockpile, so I was trying to use my LS parts that I've got and save the HCT parts that came with the kit to use in other places, because sometimes, like I guess in this case, you just have to have an HCT part. In any case, it seems to be working now, so we ought to be able to slot the CPU card back in here and run our no-op generator and watch the address lines divide by 2, just like we did before. And it appears to be doing it. Let me point you at the scope. So yeah, there's A0 counting. There's A1 counting twice as slowly. I slipped. A1. There's A2, A3, A4. You get the picture. I guess the next order of business will be to hook this mess of RAM and ROM up to the thing. What a mess. But I've got everything broken out here, the signals we need, not counting the address and data lines. I'll have to jump them off the sides of the chips here. But I'm not going to do that today, so yeah, I'll talk to you next time.